Bismillahirrahmanirrahim. Hi everyone. I hope you are all fine. My name is Azmat Ali and I welcome you all in class of Introduction to Real Analysis by Robert G. Bartle. In today's lecture, we will discuss a basic and important topic of the book, that is the composition of function. In today's lecture, our discussion will be on how can we define composite function. We will discuss example 13 of section 1.1 and theorem 14 of section 1.1. Lastly, we will discuss a question number 11 of exercise 1.1. So let us discuss how can we define composition of function or composite function. Suppose I have a two function. Let f is a function from a to b, and I have also another function g which is start from b and at c. Then their composite function, then the composite function f circle g start from a to c is defined as this is given by g circle f at x is equal to go f of x. Firstly, we discuss example 13. Later I will discuss some important points related to the composition of function. So example 13 is this example 1.1.13. Here I have a two function. First function is f of x, which is defined as f of x is equal to 2x, and my second function is g of x is equal to 3x square minus 1. We need to find f circle g and g circle f. So here g circle f at x, this is given by go f of x. What is f of x here? F of x is 2x, so simply put here 2x. We have g of 2x. Now we just replace x by 2x in the function gx. So we have g2x is equal to 3 into 2x whole square minus 1. It is equal to 12x square minus 1. Next we find f circle g. F circle g at x, it is given by f of gx. What is gx here? Gx is 3x square minus 1. Simply replace x by this value 3x square minus 1 in the function f of x. We have 2 into 3x square minus 1, which is equal to 6x square minus 1. From both composite function, we can notice that they are not equal. G circle f is 12x square minus 1 and f circle g is 6x square minus 1. So in general, we can say that f circle g is not equal to g circle f. So now I discuss some important points related to the composition of functions. The first point, you have observed that the composition of function is not commutable. That is, f circle g is not equal to g circle f in general, but sometimes they are both equal. When they are equal, case 1, if uh, f and g both are equal, then their composition function obviously will be equal. Second one, if one of the function is inverse of each other, inverse of the other, if suppose f is equal to g inverse, then their composition function f of g is equal to g of f. The next and the one of the important thing is that g circle f is possible only when we give only those values in the domain of g which are suitable for g. Mean to say, g circle f is not possible always for all values which are in the range of f. For example, suppose my function f of x is equal to 1 minus x square and g of x is equal to square root x. I want to say that here, if you find g circle f at x, this is given by g o f of x, which is simply 1 minus x square, which is equal to square root 1 minus x square. On the other hand, if you find the range of f of x, the range of f of x what is the range? The range, suppose the variable that denote the range values is y. You can see that the range values are always less than equal to 1. That means the range lies between the interval minus infinity to 1 close. So this is your range, minus infinity to 1. Now I ask, can we put any value from this range of f of x here in this composition function? Suppose, can you put here x is equal to 2? No. You know, if you put x is equal to 2 in the composition function here, your answer will be 1 minus 4, which is equal to square root 3 iota. That is an imaginary number. It means you cannot put all values of the range of f of x in the domain of g. We can put only those values of those values from the range of f of x that are suitable for domain of g. So what would be the values of domain? These values are only lies between minus 1 to plus 1 close interval. So we can choose only these values, minus 1 to plus 1 close interval from the range. So this is the important thing. Next, we discuss theorem 14 from exercise from section 1.1. Okay, now we discuss theorem 14 that can be stated as, we have two functions. First function is f from a to b and the second function is g from b to c, and let h be a subset of c. Then we have to show that inverse of g circle f over h is equal to f inverse g inverse h. That is, the inverse will reverse the order of function. We will take here f inverse outside and that we will apply on g inverse h. So to prove this theorem, I firstly want to ask, both sides, left and right, what does it show? Either these are a numerical value or these shows the sets. In my previous lecture, I discussed that when we apply f inverse is a function over a set. This always represent a set. This is always represent a set. This does not represent on any numerical value. So the left hand side and right hand side both are set. Now, from set theory or from your previous classes, college classes, uh, you remember that when we have to show two sets are equal, the technique that we used here, uh, we take any arbitrary point x from set A, and later we show that x also belong to B. And conversely, this step shows that A is a subset of B. Again, conversely, we take x from B and we show that x is also a member of A. This shows that B is a subset of A. And finally, from these two steps, we say A is equal to B. So the same strategy, same techniques we will use to prove this theorem. I will take any arbitrary point x from the left side, and later I will show that that point x is also a member of this right side, and conversely. So let x is an arbitrary element, and x belong to the left side, G circle F inverse H. Now from this step, suppose I ask x belong to F inverse A. Can we write it as f of x belong to A? By taking f on both sides, we have f of x belong to A, or we can simply say that by shifting f inverse to the left side, we have f of x belong to A. So by using the same concept here, we can write it as G of x belong to H. Now by using the definition of composition of function, you can write it as G over f of x belong to H. Now again, we can shift G to the right side, or by simply taking G inverse on both sides, we have f of x belong to, by taking G on the other side, G inverse H. Again taking now f on the other side, we can write it as x belong to f inverse G inverse H. This shows that the left hand side is a subset of the right hand side, because x is now member of the right side. We take x as the element of the right side, and we repeat the same step. So there is no need to writing these steps again. We just reverse this sign, if and only if. So this shows that equality holds, hence left hand side is equal to right hand side. So this is the simple proof. Next we move towards the last segment of the lecture, that is the question number 11 of the exercise. So what is question number 11 here? In question number 11 of section 1.1 exercise, it is given that gx is a function which is equal to x square, and my second function f of x is given by x plus 2 for all x belong to R. And let, he says, h be a composite function given by G circle F. Then find. The first part is find the direct image, direct image h of of E is given by the set x belong to R such that x lies between 0 and 1, that is the closed interval 0 to 1. In the B part, we need to find the inverse image. Find the inverse image H inverse G of G is given by set x belong to R such that 0 less than equal to x, x less than equal to 4. So to solve this question, firstly we find this composite function G circle F. Okay. Here h of x is equal to G circle F at x, which is equal to G O F of x. What is f of x here? F of x is x plus 2. So this will become G of x plus 2. Next, by using the definition of G, G is equal to x square. We can write it as simply x plus 2 whole square. So this is my composite function gx, h of x, sorry. Next we find the direct image h of e when e is the closed interval 0 to 1. In my previous lecture, I have discussed the concept of direct and inverse image in detail. Now in today's lecture, I will discuss a very shortcut technique to find direct and inverse images. I think you will consider it is better than the previous. My set E is the closed interval 0 to 1, and I need to find h of E, which is equal to h of 0 1 closed interval. This is simple. Here I say my x lies between 0 to 1. What is my h of x? H of x is x plus 2 whole square. What does this represent, h of e? This represent when we apply h over the closed interval 0 to 1, then what will be the new values of e, but my function h of x is when my function is x plus 2 whole square. In other words, my x lies between 0 to 1. I ask a simple question. When here we have x plus 2 whole square, then what is the left and right hand side of this interval? Mean to say, in other words, in which interval x plus 2 whole square lies, simply. So we make this form here by adding 2 in each part. We have 0 plus 2 less than or equal to x plus 2 less than or equal to 1 plus 2. This will become 2 less than or equal to x plus 2 less than or equal to 3. Now, by taking square on both sides, every side, we have 2 square less than or equal to x plus 2 whole square less than or equal to 3 whole square. This shows that 4 less than or equal to x plus 2 whole square less than or equal to 9. What is this? This is your direct image. given by h over e. This implies h of e is simply the closed interval 4 to 9. Now we move towards the B part. In B parts, we need to find the inverse images. I will solve this question by two methods. Method number, in one method, I will find inverse function of h of x, and in the second method, without finding the inverse function, we will find inverse images. So, method number one. In this method, I will find the inverse of the function h of x firstly, then I will find the inverse image. My function h of x is x plus 2 whole square. Let y is equal to h of x, which is equal to x plus 2 whole square. From this part, we can find x is equal to h inverse y. If we equate y is equal to x plus 2 whole square, and we find x from this part, we have, by taking square root, y is equal to x plus 2 square root. Now the important thing that that some students can mistake here, when we take square root here, there will be plus and minus both sign. We will take both sign plus minus. Why? You know the definition of square root. Square root of x square is equal to plus minus x. This is plus x if the number inside the square root, that is x, is greater than or equal to 0, and this is minus x if the number inside is less than 0. Now inside the square root the number is x plus 2. Is possible that x plus 2 could be negative? Yes, this is possible, because f of x is equal to x plus 2 and x belongs to the set of real number r. For any negative value, f of x can assume the negative value. Suppose when your x is minus 5, then f of minus 5 is minus 3. It means this factor can assume the negative value here. So we will take both sign plus minus here. From here, your x is equal to minus 2 plus minus square root of y. So this shows that by combining this x, we have h inverse y is equal to minus 2 plus minus square root y, and by changing the variables, h inverse x is simply minus 2 plus minus square root x. So this is my inverse function that have two parts. One is positive and other is negative. So now we find, my dear, h inverse g. H inverse g is simply equal to h inverse over the closed interval 0 to 4. This is my target to find. What would be the values of this set when we operate h inverse over 0 to 4? So if we take the first part, h inverse x is given by minus 2 plus square root x, and here we take the second part, h inverse x is equal to minus 2 minus square root x. When you put here x is equal to 0, the lower number, this gives us simply minus 2, and when you put here x is equal to 4, this gives us 0. So from these two values, we have the interval minus 2 to 0. But from here, if you put here x is equal to 0, your value is minus 2. And if you put x is equal to 4 here, we have minus 2 minus square root 4, which is given by minus 4. So from here I have interval minus 2 to sorry. Okay. From this I have values from minus 2 to minus 2 here. So by combining these two intervals, we have finally its inverse range is equal to minus 4 to 0. Minus 4 to 0. So this is the inverse image of G under H. Next we solve this question by second part, the second method, sorry. Okay. Next to solve this question without finding the inverse, uh, we will remember a very important key fact. H inverse G is actually is a set of all values of x, is a set of all those values, of x for which your h of x lies between this interval 0 to 4, that is the G. This is the key fact that I will use here to solve this. I will write it here. Let x belong to H inverse 0 to 4. So by shifting H inverse to the left side, or by, in other words, in mathematics language, by taking H on both sides, we have H of x belong to 0 to 4. We can write it as 0 less than equal to H of x less than equal to 4. What is H of x? Our H of x is this x plus 2 whole square. 0 less than equal to x plus 2 whole square less than equal to 4. By taking square root on both sides, we have 0 square root less than equal to square root of x plus 2 whole square less than equal to square root of 4. 0 square root is 0, 4 square root 2. Again, because there could be possible two values of this square root, so now I will write it as you can write it as, your x absolute is equal to square root x. So in form of inequalities, we convert this square root into the form of absolute when we have a doubt that this square root have two values, plus minus both. So by considering this part, we can write it as a x plus 2 absolute is less than or equal to 4 square root is 2 simply. So again, by using the result, we know if x absolute is less than or equal to some positive real number a, we can write it as minus a less than equal to x, x less than equal to plus a. So from this result we have minus 2 less than equal to x plus 2 less than equal to plus 2. Subtracting 2 from each part, we have minus 2 less than equal to x, x less than equal to 2 minus 2. this is minus 4. This is same as the previous one. So inverse images are actually only the values of x for which the given function h of x lies in this closed interval g of x. This is the easy technique to find. Hence h inverse g is simply the closed interval minus 4 plus 0. So I hope today lecture is very helpful for you. If you find my videos are helpful, kindly like, share and subscribe my channel. Inshallah, in the next lecture we will discuss a new topic. Okay, take care. See you in the next lecture. Allah Hafiz.